We've looked at the general properties of operating characteristics or OC curves. We looked at how to construct them, but what exactly do they mean? Let's take a look at how to interpret OC curves. In this video, we'll look at how to take a look at an OC curve and figure out what it means, and then also look at how different variables change the shape of an OC curve. Here's some sample OC curves. So our sample size is either 50 or 100 in these, and our acceptance criteria is either 0 or 2. Notice that the shape of these changes based on the sample size and the acceptance criteria. But before we get to that, let's talk about the probability of acceptance in terms of the percent nonconforming in the population. Let's keep the acceptance criteria in mind, 0 and 2. Here's some samples we've taken of a population. So you can see that 2 of these samples have no nonconforming units in them. This sample has 1 nonconforming unit, and this sample has 2 nonconforming units. If we're dealing with a sampling plan where C is 2, we could take any of these 4 samples and we'd be able to accept our lot. So here, the probability of acceptance of our lot is 100% based on these samples. But if we have an acceptance criteria of 0, we can only accept a lot for this sample and this sample. If we have either of these 2 samples, then we have to reject our lot because we've gone over the allowed number of nonconforming units. So among these 4 samples, our probability of acceptance is only 50% if C is 0. Let's go back to our OC curves. Here they are again. So translating what we saw out of those 4 different samples to what does this mean in terms of probability of acceptance, we see that if we have a greater number of allowed defects in our sample, we have a much higher probability of acceptance at a given percent nonconforming in the population. So let's take 1% as an example. For this plan that's in red, if we take a sample size of 50, we allow 2 nonconforming units of that, we have pretty much a guarantee that we are going to accept our lot here. And that's a probability of acceptance of 1 or 100%. If we look at our purple plan, where again we have the same sample size, but now we've tightened our acceptance standards. Now we're not letting any defects go by. So this ends up as about 65% probability of acceptance. So if we have 1% nonconforming in our population, that means that 0.5 out of 50 or 1 out of 100 is going to have defects. And if we have a sample size of 50, we may pick up a sample that has a defective unit in it. So that drops our probability of acceptance down to about 65%. So that means that the odds of accepting the lot in a randomly chosen sample with that particular plan are about 65%. If we tighten our standards even further, let's say we're doing microbial sampling, and we want to be very, very careful that we're not letting anything get by us, that our product is microbially safe. We have 100 samples and an acceptance criteria of 0 for this blue curve. If we happen to have 1% nonconforming in our population, so 1 out of every 100 units has something microbially off with it, we are probably going to pick up that 1 unit in our sample size of 100. We probably won't pick up a lot of those nonconforming units, but we're likely to get at least 1, and we can't have any in our sample. That means we have somewhere around a 35% chance of accepting our lot. So only 35 lots out of 100 are going to pass inspection with that tight a criteria. So you can see how these OC curve shapes change based on your sample size and your acceptance criteria. Here are the general rules for that. If your sampling size goes up, your probability of acceptance goes down. This is why. You take a larger sample, you are more likely to scoop up, if we're thinking about our orange balls, a ball that is not orange because you're just pulling more. And so if you're thinking about, well, that doesn't really make sense because the percent nonconforming in the population doesn't change. Yes, that's true, but you're more likely to scoop up something that is defective if you take a bigger scoop. If you have a higher acceptance criteria, so you are more lenient about how many nonconformities you can have in your sample, your probability of acceptance goes up because you can have more nonconformities and still say, yes, my population is okay. So remember those two general rules. If you have a higher sampling size, your probability of acceptance goes down because you're more likely to pick up nonconformities. If you have a higher tolerance for nonconformities, so you have a higher acceptance criteria, your probability of acceptance goes up, because you are more likely to be able to tolerate the couple of defects you scoop up in your particular sample. Notice that there's one thing that doesn't come into play here, and that's your population size. Notice that there is no capital N anywhere in here, and if you go back to the OC curve calculations, capital N, or your population size, doesn't show up there either. So it actually doesn't matter what your population size is. It all has to do with your sample size and your acceptance criteria. Those are the things that control the shape of your OC curve. So keep that in mind when you're making your sampling plan. Your population size generally doesn't matter unless you are basing your sample size off of your population size. For example, if you're taking 1% of your population, that's the only time it matters, if your sample size calculation is dependent on your population size. Otherwise, your population size does not matter, and sample size and acceptance criteria will control the shape of your OC curve.